Hi, I want to talk about all the different ways that we have to solve a system today. And I'm just going to leave this graphic organizer up and as I talk about it. We want to solve a system of equations, all right? So I have a system of equations, and I'm going to call the generic one ax plus by equals e, cx plus dy equals f. You know, a, b, e, c, d, f. They're going to stand for our coefficients. Okay, so I have some options. Prior to coming to this class, you thought about using your graphing method. Kids love that one, especially with Desmos. You can use substitution or you can use elimination. So this is what you've learned before. This is all the new stuff. This is all the stuff that we're teaching you in this chapter about using a matrix to solve your system of equations. So first thing you can do is take that system and make it into a matrix. So what we did was we took that matrix and then we used our row operations. We used reduced row echelon form. We love this one. This is Gauss-Jordan, that RREF command on your graphing calculator. We put that in and our values are going to come right back up. Or if we're doing row operations, we can also use row echelon form, just old-fashioned Gaussian elimination. And then I can back substitute to make sure I solve it. So that's a great method. But we do have some other methods that we can use to solve a system, a matrix. We can use Cramer's rule. And what Cramer's rule says is if you take E and F, your answers, the numbers that are here in E and F, and substitute them in for those values, and then find the determinant, you can solve for X and Y, which is great. Now, this does not have to just be for variables X and Y. You can also use it for multi terms, but you know, X, Y, and Z, you can use this. But Cramer's rule is fabulous. Again, notice how I'm replacing E and F for X to find the determinant in the numerator. And here, where I'm solving for Y, I'm replacing E and F there, okay? If I just have two variables, in my system, then I can go follow the other path, and I can turn the system into the form of a matrix times my variable matrix, which is equal to my answers, okay? So my option is to use the inverse method to solve there, where I have the inverse of A times matrix B. So remember, the inverse of A of a 2 by 2 is going to be 1 over the determinant, which we're reminding you is AD minus BC. And then we take the adjoint, we take A and D up here, and we switch their spots, A and D. And then we take the signs of B and C and we switch them. And we multiply that times E and F. So here, let's see, we've got, 1, 2, 3, 4, 5, 6, 7 great methods for you to solve a system of equations. Lots and lots for you to think about.